Hello students. Yesterday we discussed about the halogen derivatives of alkanes. Then we saw the definition and the classification of this halogen derivatives. We have also seen there are the 6 subtypes of the monohalogen derivatives of the alkanes. Now today we will see about the preparation of the monohalogen derivatives. First, from the alcohol. Now, from alcohol, when we can say that the halogen acid, also called we can say hydrogen halide, when it reacts with the alcohol one, it forms the alkyl halide. I have shown the simple we can say reaction one. This alcohol, there it is denoted by ROH. It reacts with HCl in presence of anhydrous ZnCl2. It forms alkyl chloride. Similarly, alcohols reacts with HBr. Now here HBr is prepared at the time of when you take this sodium bromide and H2SO4. When you take this mixture from this mixture HBr is prepared. And this HBr reacts with the alcohol and form the we can say alkyl bromide. Similarly, we can form the alkyl iodide by taking the we can say that this HI. When we react this alcohol with this HI, that is the halogen iodide, hydrogen iodide. So this hydrogen iodide reacts with the alcohol one and form alkyl iodide. So alcohol is taken, okay, and here we can say the condition is different. Here HCl anhydrous ZnCl2, we get alkyl chloride. Alcohol reacts with the HBr, hydrogen bromide. Now here hydrogen bromide is prepared during the we can say when you take this mixture NaBr and H2SO4. From this mixture, this HBr is prepared and then HBr reacts with alcohol and form alkyl bromide. Similarly, when alcohol is treated with the we can say this mixture NaI, sodium iodide and this phosphoric acid H3PO4. From this mixture, this HI is formed. This HI reacts with the we can say that the alcohol one and form alkyl iodide. Means from the alcohol you have taken the different conditions on. By taking different suitable conditions, we get alkyl chloride, alkyl bromide and alkyl iodide one. Now, first question about the action of the halogen acid on the alcohol. Now, second, action of the phosphorus halide again on alcohol. So here we have taken we can say that the two common reactions. In the first, we have taken the PX3. It is called phosphorus trihalide. It is phosphorus trihalide. So we can take here X as if we can say that is Cl, you can take Br or you can take R. In this first reaction, this alcohol reacts with the we can say phosphorus trichloride, phosphorus tribromide, phosphorus triiodide. And this reaction what happens? It forms the corresponding we can say alkyl halide. If we take here chloride, we will take here alkyl chloride. If you take here, suppose we can say bromine, we can take alkyl bromide. If you take here iodine, we can take alkyl iodide. Yes, again, in this reaction, only just by changing this phosphorus halide, we can get corresponding alkyl halide. If you want to prepare only the alkyl chloride, if you want suppose only alkyl chloride one, then we can use the another also. This alcohol reacts with phosphorus pentachloride one, then we get only alkyl chloride. So in both the reactions we have taken the phosphorus halide. In the previous first reaction we can say we have taken the phosphorus trichloride, triiodide or tribromide. We get corresponding we can say that the alkyl halide one. But this reaction, the second reaction, is only for the alkyl chloride. Means here the alcohol reacts with phosphorus pentachloride and forms we can say alkyl chloride. So we have seen the action of the we can say halogen acid on alcohol, action of the phosphorus halide on alcohol, we get the corresponding we can say that the alkyl halide one. Now suppose you want only the, we can say again, alkyl chloride one. So this we can say it is the preferable one. Here we can say thionyl chloride, that is SOCl2. When this thionyl chloride is reacts with the alcohol, we get here alkyl chloride. This especially only for the, we can say that the alkyl chloride one. Here we get the sulfur dioxide, HCl, both are in gaseous form. So in these reactions there is no need of any separation. In the previous, we can say, reactions one, here we got some, we can say, other products, so it needs separation one. Here as this we can say remaining products are in gaseous state, they can evolve and we get only the alkyl chloride. So in these reactions there is no need of any separation. So if you see these three reactions one, in these three reactions one, by the action of halogen acid on alcohol, phosphorus halide on alcohol, thionyl chloride on alcohol, we get the alkyl halide one. But preferentially, if you want only alkyl chloride, you can use the reaction of thionyl chloride on the alcohol. So second preparation now, the from alkenes. You know, alkenes means carbon-carbon double bond. When we can say that the halogen acids and halogen acids added to this across the double bond, then the addition of, we can say, HX take place across double bond and we get the corresponding, we can say that the alkyl halide one. I have taken simple example, that is the ethene molecule. This ethene molecule, it is called symmetrical. Symmetrical, we can say alkene one. Symmetrical means what? If you see the both the side of double bond, there are equal number of carbon atoms are there. When there are equal number of carbon atoms to the both the side of double bond, we can say it is a symmetrical alkene. So this symmetrical alkene, example ethene, reacts with the halogen halide, that is hydrogen halide or halogen acid. Then this halogen acid added across the double bond and we get CH3CH2X. CH3CH2X, which is the, we can say that the ethyl halide. Its name is ethyl halide. We have taken X, so X you can take Cl. If you take Cl, you can say ethyl chloride. If you take here HBr, you can say this ethyl bromide. If you take here HI, you can say ethyl iodide. So by taking different X, you can get the different halides form. So in this reaction, this is the symmetrical alkene. HX added to the, we can say, symmetrical alkene, and we get here, we can say that the corresponding halide one. As we have taken ethene, it is ethyl halide one. Now if we take unsymmetrical alkene, it is, we can say that the propene. It is ethene, it is propene. Now in this propene, if you see the both the side of double bond, one side only one carbon, other side two carbon atoms are there. So it is called unsymmetrical alkene. Now this hydrogen halide again we can say adds to this unsymmetrical alkene. Now this addition takes place according to the Marconi-Coase rule. Last year I taught you the same reaction one. Okay, so here HX added to the, we can say that this across the double bond one, it is unsymmetrical alkene one. So we get here we can say that the isopropyl halide. Again, if you take here Cl, you get isopropyl chloride. If you take here Br, isopropyl bromide. If you take here HI, you get isopropyl iodide. So here we can say that the addition of this HX is take place according to the Marconi-Coase rule. Have you remember Marconi-Coase rule? Here what happened? The negative part of the halogen acid is now X goes to such a carbon atom across the double bond which bears the less number of the hydrogen atoms. This negative part is X. X goes to the such a carbon atom across the double bond which bears the less number of the hydrogen atoms. So here this carbon bears only one hydrogen. So we can see here the X goes to the this CH1. We get here CH3, CHX, CH3. It is the isopropyl halide. So here HBr take HX addition take place according to Marconi. Now suppose in the during the reaction, if we use a peroxide, that time the addition take place according to the anti-Marconi rule. It means here we can say that hydrogen goes to the carbon atom which bears the more number of the negative part of the HX goes to the such a carbon atom which bears the, we can say that, the more number of hydrogen atoms. So we get here CH3, CH2, CH2X. We get here N-propyl halide. So if you see both the reactions, all the three reactions, symmetrical alkene, we get a simple product, that is the one product, ethyl halide. But if you take here propene, so we have seen that the symmetrical alkene and reacts with the hydrogen halide, we get the here ethyl halide. As we have taken here ethene, we get the ethyl halide. If you take unsymmetrical alkene one, like the propene one, then after the addition of HX, in first case the addition takes place according to the Marconi-Coase rule. Okay, Marconi rule is like this: the negative part of the hydrogen halide goes to the such a carbon atom which bears the less number of the, we can say, hydrogen in the double bond, across the double bond. In case of the one, if we use peroxide one, then negative part of the, we can say, hydrogen halide goes to such a carbon atom which bears more number of hydrogen atom across the double bond. Here you have to see, not this part you have to see that, we can say, double bond. Then X goes to the, we can say, that is CH2, and hydrogen goes to the, we can say, CH. Here we get the N-propyl halide. Now these two reactions are there, we get the mixture. But the major product is here in the first reaction, the isopropyl halide one, and in the second reaction the major product will be the N-propyl halide. So we have seen so far about the preparation of these monohalide derivatives from alcohol, then from alkenes, and third by halogen exchange. Now here we can say that if suppose the alkyl chloride is treated with the, we can say, sodium iodide in presence of dry acetone, we get the alkyl iodide. In this reaction, the chlorine is there, is replaced by iodine. Similarly, we can take alkyl bromide also. Alkyl bromide when treated with the, we can say, sodium iodide in presence of dry acetone, we get the alkyl iodide. So here this bromine and chlorine both are replaced by iodine. We get the corresponding here, we can say that the alkyl iodide. So here we can say halogens get exchanged. So these reactions are there where we are using the sodium iodide and treating with the alkyl chloride. It is called as a Finkelstein reaction. So this reaction is called as a Finkelstein reaction. So here the chlorine and bromine are replaced by iodine. Now there are some reactions are there where this chlorine is there, is replaced by, we can say, fluorine one. So when this alkyl chloride reacts with the, we can say that the silver fluoride, we get here alkyl fluoride. Here in this reaction what happens, the Cl is there, it is replaced by fluorine, and then we get here alkyl fluoride one. So this reaction, it is called the Schwarz reaction. So like this we can exchange the, we can say, halogens, we can prepare the alkyl halides. So we have seen these three reactions which are related to monohalide derivatives. Now suppose if you want to prepare the aryl halides, then we can perform this electrophilic substitution reaction. Means here we can take the benzene one, okay, we can use the, we can say, benzene and its derivatives one. Like suppose we can say that this toluene, it is methyl benzene. Now this methyl benzene, which is also called as a toluene, when it, we can say that the reacts in presence of the, we can say, iron in dark at ordinary temperature, in the dark, when we are reacting, we can say that this toluene one, in presence of the, we can say that the bromine one, then we get here the orthobromotoluene and parabromotoluene. In this reaction we can get the, we can say the orthobromo and parabromo. We get the mixture of this, we can say ortho and para. See again, this volume it reacts with the, we can say that the bromine in presence of iron in the dark one at ordinary temperature. Then we get the mixture of ortho and para toluene. So these products are formed. Now if suppose you want to prepare those iodized one, this can be, you can say, you can prepare the even for chloro also, orthochloro and parachloro. But for the iodine one, if you carry out this reaction, the reaction is reversible one. So for that, instead of using the, we can say that the HI, what happen? In that case, we can say that the this HI is used. So that this HI is converted into iodine one, and then we get the, we can say that the ortho and para products one. So far we have finished the preparation of, we can say, alkyl halides. Now the next part is the chemical properties of alkyl halides. So these alkyl halides are there. They contain the, we can say that the carbon halogen bond. Now if we compare the electronegativity between the, we can say, carbon and halogen, then the halogens are most electronegative than the carbon, which makes this bond, we can say, polar bond. So what happens here? This carbon is there, it becomes the, we can say that the electrophilic center. You know, electrophiles means, we can say that the positive center, we can say that. So here the carbon becomes an electrophilic center one, then nucleophile can attack to this carbon and we get the different products. So here we can say that this halogen are replaced by the another, we can say that the nucleophiles one, and we get the different products. So we can say here the alkyl halides, they undergoes the, we can say that the nucleophilic substitution reaction. So we studied that now these alkyl halides are there, they undergo the nucleophilic substitution reaction. So first we'll see substitution reaction means what? The reaction in which one, we can say, atom or group of atom is replaced by another atom or group of atom is called substitution reaction. Atom or group of atom is replaced by another atom or group of atom is called substitution reaction. When we say nucleophilic substitution reaction, then we can say that the one or more nucleophiles are there, they replace another, you can say, nucleophile or group of the nucleophiles. Then that reactions are called as a, we can say, nucleophilic substitution reactions. So here in case of the, we can say, alkyl halide, this X is the nucleophile. This X is replaced by, we can say that the another nucleophile, and then we get this different products. I have summarized all these, we can say, reaction is nucleophilic substitution reactions in this chart. See, alkyl halide, when treated with the, we can say, sodium hydroxide or potassium hydroxide, it is aqueous one. So alkyl halides, when treated with the aqueous sodium hydroxide or aqueous potassium hydroxide, it undergoes hydrolysis reaction and we get the alcohol. So here this X is there, this halogen, we can say, nucleophile is replaced by this OH. So here we can say that the nucleophile, this OH nucleophile replaces the X, we get the alcohol. Then second reaction you see now, this RX, when alkyl halide reacts with the sodium alkoxide, it is sodium alkoxide. Again here what happens, this OR, which is acting as the nucleophile one, it replaces that X and we get ROR. If suppose these both are same or different, that we see in the ether chapter. So here it is called ether. So sodium alkoxide, here OR is a nucleophile, it replaces the X. Okay, so we can get here ROR. So oxygen linkage is there, so we get here ether. Third reaction, so here we can say that the RX is treated with the silver, we can say that the salt of the carboxylic acid, the silver salt of carboxylic acid. So when this silver salt of carboxylic acid reacts with the alkyl halides one, then we get here ester, RCOOR. Here we can say that this COR, this RCOO will act as a nucleophile one, and then replaces the, we can say, this X. We get here RCOOR. So we get here ester one. Again, this alkyl halides are there, reacts with the, we can say that this KCl. When RX or alkyl halides reacts with the potassium cyanide, we get the alkyl cyanide. It is called the alkyl cyanide. Okay, here we can say that Cl replaces X. Cl is acted as a nucleophile. Similarly, if we take the AgCl, instead of KCl, if we take AgCl, it forms the alkyl isocyanide. Then alkyl cyanide RCl, the bond between carbon and carbon here. Here the bond between carbon and nitrogen. So here when the carbon of alkyl forms a bond between nitrogen, it is called iso. When it forms a, we can say, bond between carbon of alkyl with the carbon of cyanide, it is called a simple alkyl cyanide bond. So it is alkyl cyanide and alkyl isocyanide, R and C. Next, when RX is there and alkyl halides reacts with the ammonia, alcoholic ammonia, we can get the primary amine. Here it forms the, we can say that this ammonia. So NH2 is we can say act as a, we can say, nucleophile one. It replaces X. We get the primary amine. Now next two reaction, last two reactions now. Alkyl halide when reacts with the, we can say that the potassium nitrite. Then we get here RON double bond O. It is called the alkyl nitrite. So here what happened? The bond between the carbon and oxygen is formed. So it is an alkyl nitrite bond. When it suppose reacts with the silver nitride one, it forms the RNO2. The bond between carbon and nitrogen. It is called as a nitroalkane. So there are the, we can say that the 8 reactions are there. All 8 reactions, the one nucleophile, we can say that it replaces the another nucleophile. So all these 8 reactions are shown. These are the, we can say that the nucleophilic substitution reactions. So far now we can say that we have studied about the preparations and we can say properties of this alkyl halides one. See, this topic we can say that the organic chemistry, it needs a lot of practice. So every day you have to go through the, we can say that topic again and again. Read this topic because here so many reactions are there that are going to be repeated in the next chapters one. So once you understood this reactions one, it will be easy for you to study all these reactions. It's not difficult one. I'm not saying the reactions are difficult one, but the reactions, once you understood which nucleophile expresses others one, what are the reagents one, what are the conditions one, it is very easy to write those reactions. Generally we fear about the reactions, we could not write the complete the reactions one. So these reactions are simple one. Only we have to understand the, we can say that which alkyl halide we have taken and which nucleophile replaces the other nucleophile one. That you if you understood that, then it is very easy to study this reaction. So whatever we can say taken in this chapter till now, you go through it, find out your, we can say that make your own notes one. It will be very beneficial to you, so that when you study this, either any subject, physics, chemistry, biology, or we can say maths, the practice is very must. So in chemistry also, you need the practice of all these reactions. Okay, thank you.